Hello, this is Emily Wells, and today we are going to teach you the chemistry behind supernovas. Now, to begin, we first have to know the chemistry behind a supernova, a star. So, a star is basically a big ball of hydrogen gas joining and changing with hydrogen atoms. The ball of hydrogen atoms are continuously under immense amount of gravity. However, thermal pressure, radiation pressure, and fusion pushes back against the gravity, making the star have an uneasy equilibrium and a dense core. As a star grows, the hydrogen atoms join together to form helium. These atoms are constantly joining together, releasing energy in the form of heat, or as we know it, heat waves, outwards away from the star. Now I've drawn a diagram here for you guys to see. As you can see, there's the hydrogen atoms and the helium atoms, and the purple arrows represent the thermal pressure, radiation pressure, and the fusion pushing against what the pink arrows are, gravity. It kind of forms a balancing act, or it's also a battle, if you will. And then the yellow arrows are just the heat waves coming off. Now that we know the chemistry of a star, now we have to know the different types of stars. There are many different types of stars, ranging from different masses, lifespans, heat, lifespan, color, all of that. However, the one that we need to know about are the supergiants. These stars have about 10 or more times the mass of our sun. Some supergiants can be the size of our entire solar system. And if you think about that, that's just kind of mind-boggling. It's so strange. But these stars have the mass and energy to continue to change their elements and compound into heavier and more complex compounds, more than any other star. Now, however, whenever supergiants try to fuse carbon into iron, there is a bit of a problem. To fuse carbon into iron, the carbon requires a little bit more energy to do that, and so therefore it's going to take away and change direction of the energy being pushed against gravity. So therefore the balancing act is unbalanced now, or the fight as won, and gravity has prevailed. So therefore gravity is just going to kind of push into the middle and push it so tight in that a supernova happens. This is whenever the gravity will make the star explode, and then the gas that is pushed outward triggers fusion that creates a heavy metal such as uranium, and along with other radioactive gases, this produces amazing colors that we see here. As you can see, it's just absolutely amazing. It's everything that happens during a supernova. However, the fate of the supernova depends on the mass of the core. Now, if the core of the supergiant was 1 to 3 times the mass of the sun, it becomes a neutron star. This is just where the protons just slam into electrons, making them neutrons and having them able to withhold the pressure of the gravity slamming against them. Now, if the core of the supergiant was greater than 3, which is this slide. Oh, no, not that one. If it's greater than 3, then it becomes a black hole. Now, black hole is basically it's a mass decrease of gravity dramatically increases, pushing the star to about the size of the top of a needle. However, the gravity does not stop there, and it continues to push in, and a black hole is formed. The gravitational pull is so strong that not even light can escape. So in conclusion, we learned that supergiants are just huge giant stars, and supernovas happen whenever supergiants try to fuse carbon into iron, which results in an unequal equilibrium, which then gravity wins, making the star explode. Therefore, the star can turn into a neutron star or a black hole. As you could tell, learning about supernovas was incredibly interesting, and it was also not that hard to understand. You just have to kind of think about it a little bit in like a logical type way. Well, this was our presentation, and thanks for listening.